In the measure phase, we modeled our observations of reality as assumptions about causal relationships and differences to x and y. We have operationalized risky x-y pairs as measurements, translated them into content hypotheses, and converted them into a statistically verifiable format. The core of the analysis phase now is to test these hypotheses statistically based on the collected data and then to determine the root causes of the triggering influences of the problems. The identification of the root causes is the primary purpose of the analysis phase, because they are the interface for solution ideas in the improve phase. Please note that by testing the hypothesis, we can only confirm or reject our assumptions about causal relationships in reality. Statistics, however, do not provide any proof of causality, but can merely support the usefulness of our assumptions in the model. First, we will evaluate the collected data. To do so, we check the dataset for plausibility and correct or eliminate incorrect entries. In a graphical analysis, we then check their distribution and chronological profile. Next, we will calculate the process capability, for example DPMO, PP, PPK and sigma level, and we will monitor the process performance over time with control charts. Then we test the hypothesis with the highest risk value statistically with the recommended tests. We then examine the triggering influences on their root causes and thus identify the interfaces for solutions with which the root causes can be eliminated, adjusted or circumvented. The presented procedure will show all important steps of data analysis. By linking the hypothesis test with the root cause analysis, I would also like to introduce you to an analysis strategy that you can apply to your project. With the analysis phase, we also finished the scientific part of Six Sigma. The procedure in the improve phase for the development of solution ideas and implementation of concrete measures corresponds to the typical procedure of other improvement projects.